We're beginning our unit on quadrilaterals by talking about some rules concerning polygons. So you're going to fold this over and we'll start on this side. So first, some definitions and explanations. These are all examples of convex polygons, which means that all of the angles come outward like this. These are examples of concave polygons. So these have some angles that go inward into the interior of the polygon. They all have at least one angle that looks like it kind of bows inward instead of outward. So if you think of going in like you would go into a cave, concave polygons have this situation that they create where it's like one side of the shape is caved in. This is an example of a regular polygon. Regular polygons, no matter how many sides they have, all the sides are the same length, they're all congruent to each other, all the angles are the same, they're all congruent to each other. Irregular polygons have some sides and angles that are not the same as each other. So both of these shapes are pentagons. This one has 5 sides, this one has 5 sides. This one's a regular pentagon, this one's an irregular pentagon. Now, some facts about angles of a polygon. Exterior angles are when you take the side of a polygon and extend it outward. The angle it creates with the side next to it is called an exterior angle. The sum of the exterior angles of a polygon is always 360 degrees. And regular polygons' exterior angles are always congruent to each other because they're regular polygons, and that's the thing about regular polygons, every part of them is congruent. So the measure of an exterior angle of a regular polygon is going to be 360 divided by n, where n is the number of sides. So for example, this pentagon, 360 divided by 5 is 72. So all the exterior angles of this pentagon would be 72 degrees. For an irregular polygon, the exterior angles will be different from each other most likely, but they will all still add up to 360 degrees. Now, regular polygons, the interior angles are congruent to each other, of course, because that's part of what it means to be a regular polygon. And the formula for the sum of the angles of a polygon is that the sum equals 180 times n minus 2, where n is, again, the number of sides. So this pentagon has 5 sides. 5 minus 2 is 3. 3 times 180 is 540 degrees. So all 5 of these angles together would add up to 540 degrees. So to find how much each one is, I would do 540 degrees total. These are all congruent because it's regular, so 540 divided by 5 angles. For an irregular polygon, I would set all of the angles, the sum of all the angles equal to the sum of according to the formula over here. So they wouldn't all be the same, but they would still all add up to the same number, which would be 540 for a pentagon. And any pair of interior and exterior angles will add up to 180 degrees because they form a straight line. Okay, now let's open this up. Okay, so for this first problem, we want to find what is the value of x. So this is, let's see, 1, 2, 3, 4, 5, 6. This is a hexagon. It has 6 sides. So first, 180 times 6 sides minus 2. 6 minus 2 is 4. So 180 times 4 equals 720. So I know that all 6 of these interior angles are going to add up to equal 720 degrees. So let's add them all up and see what we get. So I've got 5x minus 6 plus 4x plus 14 plus 7x plus 8x minus 8 plus 6x plus 120 equals 720. Now let's add up all the like terms. 5x plus 4x is 9x, plus 7x is 16, plus 8x is 24x, plus 6x is 30x. So 30 x. And then negative 6 plus 14 is 8. 8 plus negative 8 is 0. 0 plus 120 is 120. So 30x plus 120 equals 720. Now I'm going to subtract 120 from both sides. So 30x equals 600. Divide both sides by 30. Jump around here. So x equals 20. Okay, next we have an irregular pentagon. So that's going to be 180 times 5 sides minus 2, which is 180 times 3, which equals 540. So all 5 of these sides are going to add up to 540. 5x plus 2 plus 3x minus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10 equals 540. 5x plus 3x is 8x, plus another 8x is 16x, plus 4x is 20x, plus 5x is 25x. And then, oh, this should actually be a minus 10 right here. So 2 minus 5 is negative 3, plus 8 is 5, plus 15 is 20, minus 10 is 10. So 25x plus 10 equals 540. Subtract 10 from both sides. 25x equals 530. Divide both sides by 25. And you can run this through the calculator, but it's going to be 530 divided by 25 is 21.2. Now, we didn't want to just find x, we wanted to find the measure of angle B, which is 3x minus 5. So 3 times 21.2 minus 5. 21.2 times 3 would be 63.6. Minus 5 would be 58.6. And that would be my answer for angle B, 58.6 degrees. Okay, here, let's do some stuff with exterior angles. Now, here we want to find the value of y. Now, remember, exterior angles of a polygon always add up to 360. So I know that 70 plus 60 plus 65 plus 40 plus y equals 360. So then I just have to add these up. 70 plus 60 is 130, plus 65 is 195, plus 40 is 235. So 235 plus y equals 360. Subtract 235 from both sides, and we get y equals 125 degrees. Now over here, find the value of x. So again, all of these angles are going to add up to 360 degrees because they're exterior angles. So 79 plus x plus 10 plus 2x plus x minus 1 equals 360. X plus 2x plus x is 4x. 79 plus 10 is 89, minus 1 is 88. So plus 88 equals 360. Now we will subtract 88 from both sides, which gives us 4x equals 272. Divide both sides by 4. X equals 272 divided by 4, which is 68 degrees. Okay, that's the basics of the practice problems. Let's fill in our table over here. This is going to be a really good reference for you, so make sure you get this straight into your notebook and do not lose track of it. So first, the name corresponding to the number of sides. A triangle has 3 sides. A quadrilateral has 4 sides. A pentagon has 5. A hexagon has 6. A heptagon has 7. An octagon has 8. And we often use n-gon, where n is the number of sides, like 10-gon, 13-gon, 18-gon, something like that. So n-gon is n sides, whatever that number is. And we can draw some of these. Triangle, of course. This is one of many different kinds of quadrilaterals. A pentagon looks like home plate from a baseball game. A hexagon looks like that. A heptagon looks like a hexagon, except it has an extra peak at the top. An octagon, well, I attempted to draw one. It gets pretty tricky. And then an n-gon depends on the number of sides. An octagon has 8 sides. Let's start over on our octagon here really quick. Okay, so an octagon, I'm gonna do like that. A stop sign is an octagon, so if you draw a stop sign, that would work. An octagon is like a square with all 4 corners cut off. Anyway, so remember that our sum of the interior angles is equal to 180 times n minus 2, where n is the number of sides. So a triangle would be 180 times 3 minus 2, which is 180 times 1, which means that a triangle adds up to 180 degrees. We already knew this. We've done this a lot. A square would be, sorry, not a square, a quadrilateral. A square is only one kind of quadrilateral. 180 times 4 minus 2, which would be 180 times 2, which is 360 degrees. So a square is out of 360. We've already done pentagon a couple of times. So that would be 180 times 3, which we know is 540. A hexagon we did once as well. 180 times 6 minus 2, which is 180 times 4, which we saw on the last page was 720 degrees. A heptagon would be 180 times 7 minus 2, which is 180 times 5, which would be 900 degrees. And then an octagon would be 180 times 8 minus 2, which would be 180 times 6, which is 1080 degrees, and so on. 180 times n minus 2 for any number of sides will equal the sum of the interior angles. And then the measure of each interior angle for a regular polygon, because we're talking about regular polygons here, is going to be the sum of the interior angles divided by the number of sides. So in this case, that would be 60 degrees. So like an equilateral triangle has 60-degree angles. This would be 360 divided by 4. So a regular quadrilateral would have 90-degree angles. 540 divided by 5 sides would be 108 degrees each for a regular pentagon. 720 divided by 6 would be 120 degrees. So you notice that since this is getting bigger, even though we're dividing by a bigger number each time, each individual interior angle is larger for a regular shape with more sides. 900 divided by 7 is 128.6. Don't see a lot of heptagons, they're kind of weird, regular or otherwise. 1080 divided by 8 is 135 degrees. And then for any other shape, it's going to be the sum of the interior angles divided by the number of sides. Okay, sum of the exterior angles, always 360 degrees. No matter how many sides it has, the exterior angles will always add up to 360 degrees. And finally, the measure of each exterior angle, if it's a regular polygon, is going to be 360 degrees divided by the number of sides. So for a triangle, they'll measure 120 degrees. And remember, these two numbers, whatever they are, should add up to 180 because an interior and an exterior angle will add up to 180. So another way you could find them would be to find the interior angle and do 180 minus that, but that would be more calculation usually, unless you already knew this. So 360 divided by 4. This one's 90, just like the other one was. 360 divided by 5 is 72 degrees. 360 divided by 6 is 60 degrees. 360 divided by 7, again, heptagons are weird. This one's 51.4 degrees. 360 divided by 8 is 45 degrees. And 360 divided by whatever the number of sides is for an n-gon. Okay, there's your table. Make sure this goes straight into your notebook.